Welcome to MATLAB Arduino video tutorial number 15. This video will cover visualizing geotagged temperature data using GPS and temperature sensors. We will be using the USGlobalSat EM-406A GPS module. This is a 20-channel GPS receiver with 10-meter accuracy without wide area augmentation system and 5-meter width. The GPS module is connected to the Arduino with this pinout. When the GPS shield is held with the headers facing to the right, the top cable goes to ground, next cable goes to 5 volt, the next cable goes to port 5, and the cable after that goes to port 4. These are the software serial RX and TX ports, respectively. The GPS module serial connection outputs a number of different messages, distinguished by the 5 characters after the $sign. The one we want to look for is started with GPGGA. Each value is separated with a comma and represents a value as shown in this table. We will also be using the Texas Instruments TMP-102, which is a low-power, 2-wire serial output digital temperature sensor that operates over a wide thermal range. As shown by the graph, the TMP-102 is specified for operation over a temperature range of -40 to 125 degrees Celsius. This sensor is accurate to within half a degree up to 85 degrees Celsius and has a resolution of 0.0625 degrees Celsius. Here is the pinout. Connect the supply voltage and ground to the plus 3.3 volt and the ground pins of the Arduino. Since it is an I2C device, connect the SDA to pin A4 and the SCL to pin A5 and ADD0 to ground. Let's look at how to interface this module with the Arduino. First, we include the software serial library with this line. This allows the Arduino to talk to the module over a software serial link. Then, include the I2C library with this line. Then, mode is used to hold the incoming request from MATLAB. IM is the incoming message from the GPS, incoming car will hold the incoming character from the GPS, and count will keep track of the length of the incoming message. Next, initialize the software serial connection on port 4 and 5, and store in the variable GPS. Then initialize the variables lat, latd, lng, lngd, and time. Initialize the variables byte h, byte l, temp, and temp c. Then, in setup, we start the serial link to the computer and the serial link to the GPS module. Then, we have a while statement that waits until it receives a $sign from the GPS module, which means the GPS module is ready. Then, we do the character handshake with MATLAB. In the main loop, if there are characters available to be read from the GPS, we read the next one, check if that is equal to $sign. 36 is ASCII decimal notation for $sign. If it is, that means the line has been completed and we can parse the line. If the line starts with GPGGA, then we will parse it. The following code creates a buffer to hold the line, copies time from the message, and then converts the car array into a float and stores it in time. Then, we do the same for latitude. Lat-D will hold N or S, then we do the same for LNG. LNGD will hold E or W. Then, because the message has been parsed, we reset the count. If the incoming character was not $sign, then we add the character to the message and increase the count. If there is data available to be read from the PC, read it, and then use the switch. Each case represents one of the following: time, lat, lat-d, long, long-d, or temp. After the loop, define the function getTempSent. First, request 2 bytes from the sensor, a note on the 7-bit address. 4 TMP-102 devices may share one I2C bus and read operations are addressed 72 to 75, based on the ADD0 pin configuration. Since we have grounded it to logic 0, we use decimal 72, which is found by converting the hex number to binary, then bit shifting right once. Read 2 bytes from the temperature register. As the TMP-102 stores conversions as 12-bit value, position temperatures are denoted by the most significant bit equal to 0. Bit shift the first byte 4 bits to the left to form the MSB. Bit shift the second byte 4 bits to the right to form the LSB, then logic OR the two to combine. Multiply by the resolution of the sensor to get the temperature in degrees Celsius. In the case of negative temperatures denoted by the MSB equal to 1, complement the absolute value binary number and add 1. After programming the Arduino, let's look at how to bring that data into MATLAB. We'll need the setup serial function created in the first tutorial and a modified version of the readACC function shown here called readGPS. The input is S, the serial communication structure created by setup serial. We request each value from the Arduino and save them to their variables, using the same characters from the switch statement in the Arduino code. Then we return all the variables. Then we have a MATLAB function file for converting GPS degrees in degrees, minutes, seconds to decimal notation. Decimal notation is equal to the degrees plus minutes divided by 60 plus seconds divided by 3600. Then, in the gps.m script, to read GPS data and print it. In the first section, enter the COM port that the Arduino is mounted to, and subsequently run setup serial. In the next section, we will initialize arrays to hold the lat coordinates, long coordinates, and the temperature that are sent back from the Arduino. Then we set up a figure with a button that when pushed will break the while loop that comes next. This while loop will run until the button is pushed. Get the data from the Arduino using readGPS, print it, convert the output to degrees, and add it to the arrays, if the lat and long are not equal to 0. Then we pause for half a second. Then we close the serial connection. We will start this section by setting up a string to put in the URL below. This string has the min and max of the lat and long comma separated. Then we take those and add them to the end of this URL. This URL uses ESRI, an international supplier of geographic information system softwares, ArcGIS server to grab the satellite image of the area. In this URL, we tell the ArcGIS server we want a JSON response, the size of the image, and the coordinates for the image. Then, we read the JSON response into a string and use regex to extract the link to the image and the coordinates that the image covers. The first regex line replaces quote, left bracket, right bracket, and spaces with nothing. Then, in the next line, regex looks for href and then selects everything until a comma. Then, since the regex command outputs strings, we convert the output into numbers for the xmin, ymin, xmax, and ymax. Then, we read the image from their server into the variable a, open a new figure, set the hold to on, and display the image. We have to flip the image so that it will display correctly, as with images y equals 0 is the top of the figure. Finally, we will scale the lat and long coordinates to between 0 and 24, the size of the image. Then, if the min and max of the temperature is not the same, we will set the color bar. Then add this to a scatter plot with the temperatures controlling the colors of the dots. Set a title and add a color bar for color reference. When this is run, the break window will come up and start collecting GPS coordinates until you hit the break button. Then the figure will pop up with the satellite image and the temperature data. Thank you for watching. Please visit matlabarduino.org for more videos.